Hello and welcome to episode 3 of Compulsive DIY. Today I'm going to show you how I zinc plate hardware and how I apply yellow chromate conversion coating to hardware to make it look like this during my projects and restorations. To do this, I use a zinc electroplating kit from Caswell Plating, and I've had great luck with this kit, and I think Caswell makes an excellent product. I had excellent results on the first try. So the way it's done is zinc plating is done in an electroplating bath, and after zinc plating there are various options to improve the acid resistance of zinc and also to produce specific appearances. So I'll be doing yellow chromate conversion coating, but Caswell has methodology and technology to reproduce antique cadmium plating, which they call copycad. There are other chromate colors available: black chromate, olive drab chromate, and blue chromate. So I prefer yellow chromate for appearance, but when I show you my setup, I'll show you my planned expansion because I want to do black chromate as well. I'm going to need it for my Land Rover project. In episode 1 of Compulsive DIY, I was showing metal prep of this hardware. In fact, the bolts I'll be plating today were on my episode 1. Prep is critical. Prep is the most important part of the plating process. The metal has to be shiny and free of grease, and it has to be bare, silvery looking, shiny steel. So some effort is needed, and you can see in the episode 1 of Compulsive DIY how I used tumbler, evaporust, bead blasting cabinet, and finally brass brushes to get this hardware to this ready to plate condition. Plating itself is easy and quick, especially if you have a semi-permanent setup like I do. So in a minute I'm going to go over my setup and then show you some plating and then show you some yellow chromate conversion coating. A word about safety. It is possible to do it safely. The supplies that you need to do it safely are very simple to get and very inexpensive. It is also possible to dispose of these chemicals responsibly when you are finished with them, because we're working with small quantities. So I'll mention that as well. Finally, let me talk a little bit about economics of this and why we do this. This setup can plate small quantities of hardware during actual restoration projects. So if you have a mechanical assembly that you take apart and it has bolts and brackets and small parts, while you're working on the rest of the assembly, for example, you may be waiting for bearings to replace inside some gearbox, or seals to replace in a differential, or maybe bushings to replace in a suspension. You may be repainting your suspension components, or bead blasting and powder coating the cases that these assemblies came in. While all of that is being done, you can literally take a couple of hours to prep and then plate your hardware, and it will be ready for assembly when you are rebuilding your kit, whatever it may be. It is practical, it works, and it is cost effective. The starter kit from Caswell costs $220. You'll need some additional supplies, but you'll be ready to go for a few $100s. Even if you're restoring an inexpensive, relatively modern car, the cost of hardware will add up if you try to replace every rusty bolt and every rusty nut. And of course, if you're working on antique equipment, hardware may not be available and restoration may be the only option. So next I'm going to go over the setup, and then we're going to start plating. Here's my setup. It's a 6-foot long bench with plastic covered particle board top and storage below. The top has cutouts for buckets in which all of the processes take place. I did not realize how serious I was about the buckets, but here I am describing them. I guess some people have bucket lists and other people just have buckets. At the heart of my setup, is this bucket. This is a 2-gallon plastic bucket, which they refer to as a food grade bucket, that is sold in a home improvement store where all of the logos are blue. It's the big box home improvement chain. It has this flange, and the flange is quite wide, and it has these reinforcing ribs, which may be hard to see. I don't know if the camera is focusing on them. But this bucket is especially nice to set into holes. So on the left side of the bench, outlined in gray, is where zinc plating takes place. And on the right side, outlined in yellow, is where a chromate conversion takes place. I am planning to add black chromate capacity at the extreme right end of the table, where right now I have an extra cover. I already have openings cut out there. And just a note on safety. Yellow chromate is toxic. These buckets have nice lids with rubber gaskets. They fit well. But because of the risks of hexavalent chromate, I keep an extra weight to doubly make sure the bucket is sealed on top of it. And lastly, the heaters, pumps, and anodes, and just about everything else is out of solutions. When solutions are stored, only the solution is in the container. So here is what it takes to start the process. The heater goes on in the degreaser bath. The lids come off my favorite buckets. I place a heater in the plating bath and start the agitating pump in it, and I'm ready to put the hardware in the degreaser. So the first step is the use of the degreaser. But before we can place hardware in our degreaser bucket, it has to be hung on copper wire. And so the copper wire serves as a basic hanger, but of course it also serves as the electrical conductor during the actual electroplating process. Pretty easy, just like that. And so we're ready to place this hardware in the bucket of the degreaser. Inside this pot I welded this bar just made out of a piece of a stainless steel strip to make hanging easier and to be able to put the lid on to save some of this water from evaporating. So here are the parts, and they're going into the degreaser solution. Just don't want to drop them to the bottom of this tank because the water in it is at 220 degrees. There it is, and the timer is off camera, but I will set the timer. And Caswell recommends 5 minutes, and that's roughly what I've set it for. While the degreasing process is running, we will begin setting up our plating tank. We'll install the anodes. One. There's the other. There are some interesting physics and chemistry in the lines of electric force, but if you use only one anode, you will only plate one side of your parts. So so you need two. And for complex shapes, anode placement is especially important. If, say, you have an object like a brake caliper that has a U-shaped depression or a hollow in it, that might require a very tricky and complicated anode setup. So we're connecting our direct current to the anodes, and the two anodes have to be connected to each other with this jumper wire. So the plating tank gets heated up to 110 degrees. It needs to have a pH between 5.5 and 6, and I've checked pH a couple of times in it, and it was always close. So I think buying a pH tester is optional and might save a bit more money. So it's heated up to 110 degrees. The agitating pump is running in. The electrical power is connected. So the tank is really nearly ready. While I'm preparing to take the temperature here, let me mention something about the heaters. The red heater you see in the bucket is made by Industrial Electrical Heating Supply, Inc., which is a company that Caswell recommends on their website. These are beautiful immersion heaters with very accurate thermostats. You really have to set it once, and you will have the same temperature with future use without any fussing. They also work well in plastic buckets, but they are fairly expensive. The plating bucket and the chromating bucket only need to be heated to about 100 degrees, so inexpensive fish tank heaters will probably work just as well and will be much cheaper. In the degreasing bucket, which needs to be heated to about 200 degrees, if you use a plastic bucket, you will need an immersion heater that can get up to that temperature. But if you use a metal pot, like I'm doing here, it can be placed on top of a hot plate, and you can get a hot plate for $15. You probably will not have the same control over temperature, but you'll save some money. We'll check the temperature. And so that was the timer informing us that the degreasing step is complete. Alright, so let's take our parts out of the degreaser, obviously leaving them a few seconds too long during the degreasing step will not hurt. So after they come out of the degreaser, they'll be rinsed, and we'll do a water break test on them, make sure they're not greasy. And then they go into a 3-second etch in the muriatic acid solution. Then they get rinsed in the muriatic acid rinse, and then we'll turn on our electrical supply. In fact, I'll turn it on now, let it warm up, and we'll start plating. So we're taking the parts out of the degreaser and we're rinsing them again. You make sure you can see this step. So here they are. I'll leave them for a second in this rinsing bucket. These bolts are coming out too. Yeah. And except for the little bead of water at the tip, I have water evenly covering these parts. It's not beading on them as if they have oil and grease on them, which is what we want. Here is the last washer. And so we're done with the degreasing step. So parts have been rinsed. Now they go into muriatic acid for about 3 seconds. we're doing the muriatic rinse and rinse again. And rinse off the degreaser extra well. Muriatic acid etch. And into the degreaser again. Correction, into the rinse. They've been degreased earlier, so we're rinsing them. So now let's start hanging our parts in the electroplating tank. There's the first one. You saw the current begin to flow there. A little spark. Another bolt. And now our rinsed off nuts. So now we're plating. The plating current depends on the surface area of the parts. And I calculated the surface area of the parts, of these parts yesterday using a handy calculator that's on Caswell's website. The calculator told me that I have about 3.4 amps that I'm going to need. So I will set my constant current supply to 3.4 amps, and it's taking 0.8 volts to draw this current through this electrolyte. So not a lot of voltage to pull 3 amps through the solution. The solution must be a pretty good conductor. The plating time is 20 minutes at the correct amperage to get about 1/1000th of an inch of plate on it. So let me set the timer for 20 minutes. 20 minutes is the standard plating time. You can plate for 30 minutes for additional corrosion resistance. While this is happening, a word about chromium. There are toxicities related to chromium exposure. The worst ones are from inhalation of fumes, such as, for example, when welding stainless steel, which should be done with a fume extractor and a respirator. I'm wearing a respirator here to emphasize safety, and for the very unlikely event that I'll have a massive splash event with my chromate solution and I will be inhaling droplets. That's unlikely because my bucket is secure. Disposal of chromate solution is an issue there, and we don't want to contaminate groundwater with chromates. This issue has made it into the popular culture. The movie Aaron Brockovich is about it, and these compounds are detected in groundwater all over the place. While the risk is definitely not as high as inhaling chromate fumes while welding stainless, it is worth disposing of it properly. Most municipalities now take hazardous waste to prevent people from putting it down the drain. So when the water evaporates, you can take it to your local hazardous chemical collection site. So 20 minutes have passed. The plating is done. Parts get a rinse in the distilled water after plating. Here is the silver aluminum-like colored zinc on the bolt. Hardware comes out, and in a second it's going to be ready to apply yellow chromate to. You can see on the right side of the screen the yellow chromate bucket is uncovered and there is a heater in it. It is being heated to about 90 degrees. This is the first step of the chromating process, a quick dip in muriatic acid, rinse and then rinse again. I'm doing that double rinse right now, and then into chromate. And you hold it in there until you more or less achieve the desired color. Some people mention that it takes seconds. I would say it takes maybe tens of seconds, but it definitely doesn't take minutes, and it doesn't take many minutes, and doesn't take hours. And of course, you can dip them in there in batches. I'm doing a single nut here for illustrative purposes. When the color looks good, it gets rinsed, which I'll be doing in about a few seconds here when I'm happy with the color. And after the rinse, it's hung on the line. I have a line above. It's important not to shake it off too much. The last few droplets of water still have a chemical reaction happening in them, and if you shake them off, you may have an area of the zinc plated part that doesn't get chromated. It needs to be dried fairly gently, and it takes a while to gain strength. I'm hanging it on the line above, and now I'm going to speed up through the rest of it.